Okay, hello, welcome back to another one of my video log recording sessions where I talk about genetic algorithms. The date is 2025, June 3rd, Tuesday. The time is 1:03 a.m. I should have done this video about 4 hours ago, but I was somewhat procrastinating and simultaneously thinking about what I should say about what I'm going to cover today. So, but I think I might generally have it, but we'll see. So, in my last video, I left off with the finding that introducing lower base mutation rate and then introducing individual mutation rates based on that base mutation rate greatly helped the entities converge to what is supposed to be the true ceiling, or what are supposed to be the true ceilings across all eras. Of course, there are some fluctuations, but the point was to keep the candidate percentage as low as possible, and that is 0.2 or 20% with the learn rate method. I should write that down. So the purpose was that to keep the learn rate method and the candidate method and candidate percentage to this is proper tail, and then XP tail as an exponential tail, and then 0.2 as in 20%. So the purpose of all that was to find a way to keep this setting, and the reason for wanting to keep this setting is that I don't want to have to use a setting where I have to raise the candidate percentage to anything close to or above 0.5. So keeping it to 0.2 is a move in the direction that I want. And the reason I want that again is that I don't want to have to make or force the entities to, I don't want to force them to go through, or I don't want to, rather, let me rephrase this. I don't want to force them into having to go through the learning process, the learn process from top entities. Of course, it is good that they learn so that they don't eventually get struck out, or they don't eventually get limited out, which doesn't usually happen because now I shuffle the world right before the generation ends. But the point was to provide as many entities as possible the right opportunities at the right time, so that they get better over time in terms of summed utility values. And the purpose of the learn method was exactly that. And also the purpose of having a lower plus a lower base mutation rate is also that. But again, coming back to coming back to a higher candidate percentage value, if I have the world here, and if I, for example, have 0.6 or 60% of the entities learn, that means if I have 1000 entities, that means 600 entities will have to go through that process, which is, as a result, which is a huge amount of additional computation that has to be done. So I don't think that's wise for now. I think trying to keep the amount of computation within a certain relatively low range, or the lower end of what it could be, not as lowest as possible, but on the lower ends, so relatively low. And of course, doing 20% of this is far less than doing 60% of this, so keeping it at 0.2, that's my that is one of my intentions. And to do so, because with the initial setting, that is proper tail xp tail 0.2, before the lower base mutation rate and before the individual mutation rate for entities, this whole setting wasn't exactly converging to converge, not all the time, or not as often as I would like. So I also mentioned in one of the previous videos that one way to find or make it converge, make any one of the entities, any number of the entities converge, is to keep throwing more entities or more generations into the evolution iteration, into one iteration of one evolution that is probably 1,000 generations with 1,000 entities, and then I would increase that to 2,000 generations with 1,000 entities, or 3,000 generations with 2,000 entities, and so on and on. And sure enough, given enough numbers, some entities would converge. But the only downside, but a big one, is that it will take more time. So time, oops, I don't know why I'm drawing like this, but I felt like it for the purpose of emphasis. Time is very important as well, and not giving enough time is bad, but taking unnecessarily long or longer time to compute and to complete the evolution, complete the n number of generations of evolution within one iteration, is also bad, because it literally slows down the process of researching, or process of doing anything. And that is why the individual mutation rate was introduced, and that is why the lower base mutation rate was introduced. So that's all good, but so far, and that's why 0.2 stays 0.2 candidate percentage. But so far, seems that I missed out one very blatantly obvious and crucial thing. That is, what color do I want this in? Okay, fine, red is fine. That is population. Or sometimes the concept of max population. I forgot about that, because and what I forgot in detail is that if number of entities, if number of items, not entities, is lower, or rather, let me rephrase that, lower or smaller number of entities would usually require let me, where's my cursor? No, that's not. Requires small. No. You would usually need, for smaller number of entities. Wait, I'm all over the place, aren't I? Okay, given enough generations, smaller number of items. For smaller number of items, you need only a smaller population. Not to be confused with initial population, because they're kind of similar but not the same. But they can be the same in number, in size, but they're not exactly the same. But anyway, smaller number of items mean smaller population for convergence. And of course, bigger number of items means you need a bigger population for convergence. And this was quite apparent when I tried when I was doing the max constraint percentage and peak plateau plots, and when I had 100 items, the entities were not peaking to its actual true maximum potential, with a true ceiling, given a maximum constraint percentage of 100%, and they would just kind of stop going up, stop increasing. The peak level and the heads would stop rising, and then it would just not be there. So in order to see what I need to do for that to happen, at that time I also increased the population, if I remember correctly, 3 times. So if it were 1,000 entities, I increased that to 3,000. If it were 500 entities, I increased that to 1,500, or even 2,000. And then I was able to get some entities converging. But in my previous videos, my last few videos, since I am doing things dynamically, in quotes, I could, as the number of items change, and of course along with that as the maximum constraints change, I can also change the population size. So what I did was, I'm not going to say for example, but what I did was what I did was for num items, if this is num items, and then if it was 10, and then I would have 20, and then I would have 30, and then 40, 50, I should change the color, and then 70, 80, 90, 100. And then for the population, and for the population size, which is pop size, and also in this case the maximum population, which was 1.0 times pop size. You just keep that in mind. For pop size, I just increase it by 100 per era. So because now there are 10 eras, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, just as in my last few videos. But the population size will change from 100 in the first era, then to 200, then to 300, 400. You get the point, right? Then 600, 700, 800, 900, and then 1000. Yeah, 1000. So that's what I did, and everything else stays the same with the with all the concepts introduced before staying. So we still have lower base mutation rate, we still have individual mutation rate, we still have the learn rate candidate combination the same, purple tail, XP tail 0.2. The only thing that changed is the setting, where the population size changes with the era, or as the era changes. If the number of items increase, the population size will also increase. Okay? So that's what I did. And well, here's the first result. I have to say, I also kept on using the lower max constraints. It's a list, but it's still lower, means lower max constraints. So where the max constraint is usually around 65 to 70%, I believe, of the total sum of constraint. So when I did that, this is the first setting. The first thing that I did is exactly this. So we have 10 eras. The number of items will change from 10, start from 10 and increase until it's 100. Population will start from 100 to 200, 300, and all the way to 1000, with individual mutation rates and using lower base mutation rate as for computing the individual mutation rates, where the base mutation rate is 0.01 or 1%. Hold on. Yeah. So when I do that, just hold on. Let me just get that. Just checking. Yep, base mutation rate in this case was 0.01 or 1%, and this is what happens. This is the shape of the distribution. As you can see, it gets cut off. No, let's not review it here. I want to keep this. It's a good picture. So, well, I'm only just going to look at this briefly, just to see. And well, it's not exactly a normal distribution. but this is by now I have come to accept that this is the usual, because well, if it goes anywhere above here, it means they get struck out, so it's natural that entities here don't exist. So this is nothing unusual, right? And this is what you get. So here yeah, in this setting, for 100 items, in this setting, for 100 items, the true ceiling is 28665, as we have established in the last video, I think. Or not. Oh no, that was a genuinely authentic, real. Oh no. The reason what is this? Go away. The reason I even thought about making this video was that before thinking about having to introduce the idea of implementing changes in the population size, the true ceiling for 100 items I thought was 2860, and then I did this, I got 2855. So for which I wasn't really supposed to get, because well, was I really supposed to get that or not? Well, which was kind of expected. That's you know, a mild way of putting it. But I always like to try the same setting once or twice more. So in total that's 2 or 3 times. And then the next time I ran the same thing, ran it, and I got 2860. Yeah. So where's my mouse? Yeah. So the next time I ran it, it was this one. I'll show you the distribution again. Very similar. Next time I ran it, this is what I got. Now it was 2860. So I thought, oh, where is it? I'm really, why do I keep doing that? As you can see here, now we have 2860. So, I thought, I said to myself, that's interesting. You know, it's still, oops, no, oh my god. Because the reason I thought that was interesting is that because there were only 100 entities there, and then 200 entities there, same thing with here, both of these, 300, 400, 500, 600, 700, 800, 900, and 1000. And if you just add them up, like in a very simple down version of doing the mathematics behind it, if you just add these up, it's only like 5,500. Is that right? Yeah, I think so. 1, 2, 3, 4, 5, and 55 times. Yeah, it's only 5,500 entities on paper, on the surface. I would like to say, but I'm still getting the same results as. Where's my mouse? Okay, I'm still getting the same results compared to when I had 1,000 here, 1,000 here, and 1,000 here. So So I just had to compare this to that one, which is, oops, compare this to the very last time I had, when I had when I had 1000 entities per era. And if you look closely, or let me show you a very cheap trick. That's not it. Was that it, actually? Let me try this again. This is... yeah, so this is when I had incremental population. And then this is when I had 1000 entities per era. See, if you look closely, you'll see that the overall levels of all these lines, of all these plots, are higher when I use population size that increases with era progression. So let me do that again. This is from, this is 1000 per era. Sorry. And this is 100 to 1000 as the era changes, moves on as time passes. So it's a concept of it's the concept of society or population slowly growing as now there are more things that entities can do, or people can do, and more of what they can take on, and etc. So right now, oops, these two pictures are on the same scale. Yup, on the same scale, and you'll see, I'm just going to be very, very rudimentary. You'll see that for every level, it's higher on the right. So those are for the tail entities. And this is the last one. If you want to see the head entities, they're about the same, but because they're the heads, you converge here, here, here. You can only converge to a certain level, a fixed amount. But what's interesting is that here is the shape of these so-called steps. Yeah, the shape of these steps. On the left, you tend to get more steeper steps, more like a right angle. You know, I know this isn't a right angle, but when you compare it to this, these steps are rounder. Where they can be round, they will be round. Whereas here, they tend to be more angled. I mean, you do see some roundness there, and especially there, because you can't really be anything else. I mean, maybe the setting here that's going from 50 items to 60 items, but that's because the maximum constraint in this case didn't increase by a lot, so you can only be so much different, so much higher. But in this case, going from 60 to 70 items, when we still had 1,000 items per era, compared to how do I do this? How should I do this? Comparing this to this, where is it? Here. This is a bit more round. See those? Yeah. I know it doesn't really show that. Doesn't seem to be as you know what I say, but you can start seeing this more and more. Start seeing this phenomenon more and more as I show more plots. And again, when you have increasing population size towards the very end, that is 100 items, they converge a lot better. I know it didn't converge to a true ceiling. For both of these cases they didn't, and this is when I thought 2060 was the best. I still thought that, but anyway, they still did converge to 2060. Not exactly the true ceiling, but I'll get to that later. But they still did. But here, if I have incremental population sizes, the entities converged a lot earlier than before. So it led me to think that doing it this way being introducing the idea of increasing population sizes in a procedural or a linear way, as in what that entails is this: if in this case this is not the world, this is items. This is shoot. If this is items, all items, and their values and whatever, the way this is done is that this would be the first 10 items. This would be the first 10 items, and then next second 10 items, third 10 items, fourth 10 items, on and on and on, until it's all of the 100 items. So the items that were included in the era before still stay. So it's kind of like a progress or a procedure or whatever. It's in one linear fashion still. I am working on a non-linear or a non-telegraphed way of picking different numbers of items per era in a different fashion, but that's another story. But so far everything is linear. The ones that used to be will stay. The items that were in the previous era included during the previous era will stay. Yeah, that's the right way of saying it. And as the number of items increase the population size, as it tends to help entities converge faster. And I must say I should I may have to say think the right way of saying it is I may have to attribute this behavior to the fact that when an era changes from one to the other onto the next one, the number of entities that needs to be created skyrockets by more than 100, because that's how the code was written. And when that happens, all those new entities will be the result of procreation or procreations amongst the entities, half of which are very likely to be from top 10% of the entities in the world. And so when the era changes, very quote-unquote elite entities will be newly introduced into the world, and that's what drives up the overall level. Yeah, now I have that all sorted out. So that's what happened in the first run. Moving on. This one. Oh, well, first one and the second one, actually. The third one that I did was I tried it out for fun. And the general idea here was that would it actually make any difference? Why is it not working? Would it actually make any difference if I were to start from the back, as in a reverse list, you know? So I would, for the first 10 items, I would start with this, and then for the next 10 items, I would start with this, add this for the next 10, add this for the next 10, on and on and on, until 100 items. Because I think, I'm not sure yet, but I think the order in which the entities are introduced to the items, or rather the order in which the items are introduced to the entities, may matter, may shape the way or the direction of the evolution in general, because it's quite likely that it creates a bias, but I don't know that for sure yet. But so I tried that. So this one I did it from I did it with a reverse list or from the back, and this is what I got. And this is when I definitely thought that I would have to make this video. 2865. That's a new true ceiling with this setting, with the lower maximum constraints. This is the new true ceiling. So now it's 2865. And then the next one gave me 2855. Should I show that? Okay, fine. There we go, 2855. And the next one also gave me, still doing it with a reverse list. So still doing it from the back. Next one gave me, what did it give me? 2860. So still very close to the, this was the previous true ceiling. And for the last one, the last time I tried this, because I was so, well, I didn't actually, I was so fascinated, and the way I thought about it was that maybe I should come back to the original setting with the order of the items list and the values list and the constraints list back to how they were before, and then see about it. So I did that, which is this one. And now, as if someone was playing jokes on me, with the same setting, exact same setting, I got 2865. Which leaves me two things to wonder. Number one, is this really the one or two things? Is this really the true ceiling? Number two, is this the right way of finding them out? Well, I think the second question is a lot more serious. And lastly, for this with this setting, I tried it with what did I try? Again, just to make sure if this was right, if I can get 2865 again. I tried it in one go with 1000 entities, and for some reason I got 2865. Now I'm starting to get 2865, and this was the shape of the distribution. And because entities have been converging to the true ceilings for so many generations, probably after about generation 400, and then for the next 600 generations, all the entities have just flocked together towards the very end of what is supposed to be the supposed true ceiling. So, let me just take a sip of water. Okay, now I'm back. But there's always a but, isn't there? It's a good but. In this case, the most surprising thing was, or is, that, where's my mouse again? There we go. Is that, remember what I said about, if you remember what I said about time being quite important, being one of the very important factors. The time it took to do this was around 60 seconds, give or take 1 or 2 seconds. Plus minus 1, 2. Or maybe sometimes 57 or 59. Yeah, let's just put it at 57, 59, or 58. I think that's a better way of writing it. Let me just get rid of that. I'm so unorganized today. Sorry about that. 58 plus minus 1 or 2. The most surprising thing here, the biggest difference here, is that with this setting, where I have the population size increase with era, it took 38 seconds. Give or take again 1 or 2. So this is way faster, and it's again, I say this very often, it's obvious why it's so faster, because now I have on the surface entities that do surface per generation, per era, are fewer in number, or are fewer in numbers per era, because this was 1000 in each era. Here it's 100, 200, 300, and then so that's 5, 5, 0, 0 on the surface. This is 10,000, so almost half, slightly more than half. Again, 55%, but still, who's counting? I'm counting. So if I do the math, 58, this is like 66% of the time. 38 seconds is 38 seconds is 66% of 58 seconds. So about 34% difference there, because fewer entities are involved, and therefore fewer entities are created, and fewer entities are limited out, fewer entities are struck out. So this setting is also smaller in terms of volume on the disk space, disk space. That's so hard to say. So that's the biggest difference, and I think that is a huge advantage. So I thought about leaving this at that, leaving this at this, but unfortunately another idea came to me, and then I thought, let's just try one more thing, and that is what I did in one of my previous videos, where I had the era change in a responsive or an adaptive manner. And in this case, the era would change and move on to the next era, progress onto the next era, when you have enough values for head within a given window of heads in terms of their summed utility values. So, for example, if the window was about 10 values wide, if there were for example three instances where the maximum value had occurred 3 times, instances where the maximum value in that window happened 3 times, it would qualify as being converged and then move on to the next era. Of course, the final setting that I used was where the window was, let me just look again, I should also save that, yeah. Where is it? The first setting was where the window was 10, and then if I had equal to more than 0.3, which is 30%. So if 10 last values for head entities, if out of those 10 values 3 or more of them were the maximum value within that window, it would qualify as being converged, or rather entities would be deemed as having converged. The second one was 10 and then 0.9, or that is 90%, and then the third setting was where it was where is it 20 last head values and then 0.6, so 60% of them, so that's 12 values, and that's 9 values, and this is 3 values out of 10. And when you do that, yeah, what's that one? Yeah, and when you do that, this is what we get. Oh yeah, I'll just go through. Is this it? Yeah, this is what we get. So it's almost as if there were no eras, because you see that the eras just changed almost instantly. And that's because having 3 out of 10 as being the threshold for qualifying as being converged is actually too low. That bar is too low. But and the maximum ever was 2860, so it didn't get the true ceiling there. The next one I tried was probably raise this value to 0.5. I think that was it. And here's the distribution, yeah, and here's what we get. So now you see more steps here. Now the eras actually show on the summed utility plot. But no buts, not yet. And the maximum ever was the true ceiling, what is known to be the true ceiling. Yeah. What was I going to say about after but? I have no idea. But anyway. So I tried it again. But now with a higher threshold, that is 0.9. And now the steps will be more more distinct. Yeah, the steps are now showing more distinctively. Look. And the max ever was 2860, so a bit unlucky there. And then the next setting I tried was also the same thing, just to see if I was actually, or if it was actually misfortune, which turns out it probably was, because now I got 2065 as max ever, which is the true ceiling for now. So, well, that's no fun, I thought. So, and then that's when I increased the window size to 20, and then set the threshold to 0.6 or 60%. So that is, I have to get, if there is a max value, I have to have 12 of those in this window for this era to be over. Is that it? Yeah. Is that really it? Yeah. Here's the distribution. So, nothing unusual. And here we go. Now we see the steps even more distinctively. The steps are showing more clearly. And then we did get 2865, the true ceiling value. But there is one caveat. I mean, oh yeah, I forgot to mention, in this case, because they converged in each era so fast, or entities thought they converged in each era so fast, that first it was 1000 generations. The total maximum generation was set to 1000. And then I decreased it. Again, it's 1000 here. I decreased it to 600 because it was apparent that it was enough. 600 was enough. I could have set it to 500, but I wanted to give it a bit of a leeway there, so I set it to 6. I give the entities 100 more generations. So now it's 600 generations. So that's good compared to the 1000 generations that you have to run this and compute. 600 generations is a lot shorter. And where is it? It's the same thing. Yeah, so 600 generations. But there's one caveat. I should bring that back. So here, this is responsive or adaptive. I'll just write resp. Maybe I should move this to here. Yep. So responsive, and responsive as in the eras would change as a response to the entities having converged or not. And as the era changes, again, like I've said for 100 million times, the number of entities per era would increase by 100. So something like that, yeah. But it took 58 seconds, give or take 1 or 2. Even with 400 fewer generations to compute. And a way to explain that is that remember how, like, on the very surface of each within each generation and within each era, there are 100, well, 200, 300, and so on entities per era. But here, the width of an era or the length of an era are different. They may be longer as things progress, and for the last era it just stays in the last era. So we only have this short of an era where we have 100 entities on the surface. And then we have a slightly longer era where we have slightly longer era in terms of generations where we have 200 entities. Slightly longer, 300. About the same, 300. Maybe slightly longer, 400. Maybe about the same, 500. You get the point. You get where this is going. A lot longer, 700. 700. Somewhat longer, 800. And maybe here, 900. But shorter. But all of this, 1000. So this on the surface is more than 5500. And now we have why did I write 10,000 there? 1000 there. But now we have 1000 entities. Let me just erase that. 1000 entities during all of these generations. So it actually takes longer for this to compute. 58 seconds. And because the combination of items that are involved in each era are somewhat inclusive. They're not exclusive, they're somewhat inclusive, as in they're linear, as in they do change, but what was there before stays. So first 10, oh my god, give me the blue one. First 10 items, second 10 items, third 10 items, fourth 10 items, and this goes on until the entirety of 100 items and their related values. But the thing is, per era, or all the eras are somewhat related because the items that were there stay. So it is quite likely that these are not very independent from one another. So it's quite likely that entities with higher utility values here, some utility values here, would have not probably the best, but somewhat good values here. And the same here, and the same here, and the same here. So in a way, the knowledge, or the information, or the knowledge, or the tradition continues, the convention continues onto the next era. It's the same here, but when you give more than enough generations, more than enough time for the smaller population sizes, it means that the entities will overconverge here. The entities will overconverge here as the era is about to finish. They'll overconverge here. They'll overconverge here. They will overconverge less and less as the era progresses, of course, because it's a lot harder to converge and overconverge with more items, given more items. But the entities will overconverge towards the end of the earlier eras. And because this knowledge gets transferred, it is somewhat easier for the last few eras, during the last few eras, for the entities, not this, for the entities, oh come on, give me a good color. It is somewhat easier for the entities during the last few eras to use the knowledge gained from here, whether they're new entities or somewhat old or older entities, relatively older entities, to use that knowledge to converge. So giving more than enough, or what's more than enough generations per era during the earlier stages here may seem like a waste of time, but it helps for the entities in the later eras to converge faster, and you still get a somewhat of a healthy looking distribution, as can be seen here. It's not that healthy, but I mean, it's missing some bits of its right tail, but yeah, it's what I have now come to accept, the reality and the fact, and now I would accept that as a satisfactory shape. But anyway, I digress. Yeah, so giving more than enough generations during the earlier eras will help the entities in the later eras converge faster and better. Or as opposed to this, if the era changes in somewhat of a, you know, in somewhat of a more relatively premature fashion, the knowledge here doesn't happen, doesn't accumulate. And in this case, by knowledge I mean more entities converging or being close to converging. More entities in the state of being converged or nearly converged, rather. Yeah. But in a way, that's kind of against almost exactly the opposite of what I said about wanting to have a healthy distribution shape, robust. But it's a trade-off that I have to make if I want to have the entities move through eras. Which is why I drew that here. I was thinking about it, and this, just unlike the previous drawings that I made, just turned out to be quite pretty, so I think I'm gonna keep it. Okay, I'll just keep it here. Yeah, good. No, go away. I didn't want that. So, that's about it for today. I think. I might have missed a few things, but I mean, I always do, so I'm not surprised. So, conclusion for the takeaway, the lesson learned today is for a lot of items, when doing genetic algorithm concerning or involving a lot of items, have them line up, do it in a linear way, so that the items involved in the previous stage would still stay in the next stage, and call that stage an era. The name doesn't really matter, does it? But anyway, I would call that stage an era, and then give each era, or give earlier eras, somewhat of a more than enough time or generations for the entities to converge. And even when you do that, for the very early or first few generations, or the earlier generations can have fewer entities when compared to the later, no, sorry, the earlier eras can have fewer entities compared to the later eras, where you do need more entities than before. And this is a lot more efficient than just throwing the maximum number of entities or maximum population and then doing this whole thing in one era of some number of generations, in this case 1000. But just because this is so doesn't mean that doing it with responsive eras may not necessarily be more efficient. It might be effective, but it might not necessarily be more efficient in terms of time required or time used for computing, because on the surface you have more entities that are involved compared to when you do this one in the middle. Yeah, that's about it. No wonder it took me so long to mentally prepare for this. I'm still not prepared. Okay, but anyway, that's about it. Thanks for listening. Wow, it's 72 minutes. Holy. Okay, see you next time. Bye.